So we're looking at your triangle proportionality theorem homework, and we skipped 1 through 7 because everyone said that those were easy. Those were basic application of the theorem. Starting with number 8, it says mixed practice, which means you can't always use the theorem. Let me teach you when you can use the theorem and when you can't use the theorem on these problems. Let's look at number 9. In number 9, are these segments parallel? Yes or no? Are the segments parallel? By the converse of the corresponding angle theorem, they are. If two corresponding angles are congruent, then our lines are parallel. And a lot of students just assume they're parallel, and that's fine. That's not really what this unit is about. So actually, we can use the theorem to find y. We just can't use it to find x. So when we're finding y, we're allowed to do this. Circle is to circle as square is to square. This right here, this segment, splits the sides of the triangle proportionally. It splits them proportionally. That's the theorem. So it doesn't matter which one I start with. Square is to square as circle is to circle. Doesn't really matter. You cross multiply, you get y. Okay? You're allowed to use the theorem on y. You're not allowed to use it on x. In the theorem, it says nothing about the length of the sides that are parallel. So to find x, while you're getting used to it, you might want to draw those two triangles separately. X, y plus 6, 10. See where I'm getting at here? 4, 6, y. I went ahead and put all the dimensions. If you're finding x, you wouldn't have needed the y. What's important to remember is to add the 6 and the 4. To find x, you can't just use 6 is to 4 as 4 is to x. You need the whole side. That's why I tell you to draw it separately. So we already found y. We don't need that. So now I can do underline is to underline as circle is to circle. So you draw them separately unless you can just visualize yourself adding them together. So 6 is to 10 as 4 is to x and cross multiply. Number 10, we'll see a lot of problems like this on our worksheets and review and test. What we're focusing on is the triangle. So we're not getting distracted by the extra segments drawn in the picture. We don't want to get distracted. We really don't need that stuff right there. These two triangles, the green and the red, they're already similar by angle-angle similarity. We did not even need those right angles over there. So I'm going to focus on the triangles only. We need to figure out which sides go together, which sides correspond. The ones that are horizontal, those are easy. 5 corresponds to 25. What's across from the single arc? It's 17. I'm going to box it. What's across from the single arc? Oh, it's x. So I'm looking at what sides are across from the marked angle. And then whatever's left over, 14 is across from nothing, I'll underline it. Y is across from nothing. So now I know what goes together. Circle is to circle, as box is to box. Circle is to circle, as underline is to underline. Can you solve this the scale factor way? Absolutely. What's the scale factor? 25 divided by 5. Scale factor is 5. So when you're going from small to big, you multiply by 5. If you're trying to go from big to small, you divide by 5. So you could just do 14 divided by 5, 17 divided by 5. But if you don't want to do it the scale factor way, cross multiplying always works. All right, 14, find the distance across the river. We cannot use the triangle proportionality theorem here, because what the theorem says is that when I have, this is parallel, by the way, because it says that they're similar. When I draw a line parallel to the side of the triangle, it splits the sides proportionally. Ooh, but we don't have those boxes. We have 75 and 100, which is not one of the sides that got split. So we need to draw this one separately. That's what I recommend. Redraw them separately. That small triangle is x and 75. The large triangle is 100 and, just be careful, the side of that larger triangle, The side is not x, it's not 25, it's not 25x, it's x plus 25. Now I can set up a proportion. 75 is to 100 as x is to x plus 25. And just like in the warm-up today, we will need to distribute. 75 times 25. Then subtract 75 and divide. Divide by 25. All right? 15, when you read the problem, it sounds really complicated, but then you look at the picture and you're like, they already drew a picture and they already labeled everything. So really on 15, it would be great if you had to draw your own picture, but they did not even make you do that. You're just trying to find x. I'm going to, on this one, since on the other one I already redrew the triangles, I'm not going to redraw these. We're going to try it without redrawing. So I know that 6 goes with x, so I could say 6 is to x as 8 is to, and this is where I need to be very, 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 very careful. 6 is to x as 8 is to, good, 50, not 42. You do need to add those together. And then you cross multiply. 17, this comes up a lot in the real world. There are ramps everywhere. By building code, there has to be ramps on many buildings. And a ramp just doesn't like hang out suspended in the air. It does need segments, wood pieces, steel pieces to support it. So we want to find out how tall those pieces need to be because we probably had a certain slope that our ramp had to be according to the building code. So what we're going to do here is take 2 triangles at a time. We're not going to look at all 3 of those triangles. We're going to take 2 at a time. So I would say 1 is to x as 2 is to, and that's where we need to be careful. If we're not going to redraw this, then we need to be careful. 1 is to x as 2 is to 5. Everyone understand where I got 5? Not from the other part of the diagram, but from 2 plus 3. So you cross multiply that, you get 5 halves or 2.5. Then you use the 1 and the 2 again. 1 is to, we'll call it y. 1 is to y as 2 is to, now we need the whole side. So 1 is to y as 2 is to 10. It almost looks like the exact same proportion, but we just changed the side of the triangle. This is a new triangle. So fine.